Hello everyone and welcome. This class is going to be about lambda expressions. I'm assuming you already know what lambda expressions are and what they're used for. There is so much we can say about it, and every day new functionality are being added to the language. However, this video is going to give you enough information to build and understand an implementation of lambda expression. Let's get started. So the first example, it's an inference type. In fact, we are declaring the input parameters, we are declaring the body function, but we are not declaring the return type. This is expected to print 80, right? Let's see what happens when we build and run the application. As usual, we copy and paste this line over here. It just makes it easier. And then we build including the Kotlin runtime. And then when it's ready, we run it. As usual, we need to run it as a jar. And here it is, 80. And the second example, it's the declaration one, as we are declaring the input and the output type. And that's the body function as usual. Now, as we have integer and string, when we try to do this, instead of getting 11, we're going to get 101. Let's see what happens. As usual, we run the jar, and that's it, 101. The next example is going to be interesting because we're going to extend the capability of classes. Now, in the previous video, we've already done that by using class extension. Here, we're going to be doing something similar by using lambda expressions. Now, here, we create a method or a function, and then we pass a string, an integer, and we return a string. And here, we create the lambda expression. This lambda expression is going to be run on a string, is going to accept an integer, and is going to return a string. And that's the body function. All we do is grab in this square bracket, and then we append this, which is the object itself, the string, and then we append it to the object, which is the parameter that we pass to the lambda expression. In this case, it's just a single number, and we're going to be talking about this it later on. And then we append at last this square bracket again, just to close the string, right? And eventually we return the string. It's like calling a method on an object, right? We have this paste over here with the dot notation. And then what we expect is getting this 1 over here. Let's see what happens when we actually run the program. Here it is. Works as expected. Let's have a look at the source code again. Right? 1, 1, this, it. That's a very convenient way to extending class or object. The next example is going to teach us how to use lambda expressions to simplify for each cycle. Now, you declare your array, and then you start cycling. Just remember how we managed lambda expressions before. So we are saying that for each item that gets returned, we just double it, and then we print it to the screen. This line over here, it does exactly the same thing, but it's even shorter, and it's using it like we used it before. So here we are saying every parameter that gets returned by the for each is going to be multiplied by 2 and then printed to the screen. So once again, the lambda expressions, they don't do anything you couldn't achieve with other lines of code. They just make your code much smarter and much more readable. And here we're going to turn lambda expressions into pointer to functions. So here I created my custom function, but you can also use something that already exists. And here I have my lambda expression. So here I'm accepting two integer, I'm returning an integer, but the body function is here. So this is supposed to be printing 7. Let's see what happens when we actually run the program. As usual, the jar. And here it is, 7. And now I'm going to show you how to manage lambda expressions that have a return statement. So I created my class translator, which has two properties. The first one is the language that my system is able to understand, and the second one is the language that the user is requesting. Now this is my init block, and here I have my translate method, which is accepting a lambda expression, which is accepting no parameter and returning a string. The lambda expression is called lambda, and the translate method is returning boolean. The lambda expression is going to stay dormant until I invoke it, and if it's returning English, the method is going to return true, otherwise it's going to return false. In the main, I create my translator object, and then I call the translate method. Now, as you can see, I need to use this special syntax. So I need to label the block of code that contain the return of the lambda, and also I need to label the return itself, also because there might be other return of other method, nested method, or whatever. So you need to specify which kind of return is this one. Now, as we've seen before, if the user is requesting English, then we can proceed. Otherwise, we need to stop and return option is not allowed. Now, let's see what happens when we actually run the application. Java, jar. Okay. Checking settings and translation in progress. As expected, right? Because we are passing English, right? The last topic I want to cover is scope functions. These functions do not work exactly like the usual group functions such as map, filter, or for each cycle. They actually create an additional scope where your data is going to be placed and where retrieving your data is going to be easier. Now, at the moment, these are the scope functions which are available: let, run, also, apply, and with. Apply is useful if you need to call several methods on an object. Return values are not important. As you can see here, we are updating so many items price just with this line of code. And we are not checking the return value. With is similar to apply. Let, if used with a question mark, it gets a result if a value is not null. As you can see, we are getting the full name just when we are able to retrieve the complete data. And that will be all for today. Thank you very much.